In this video, we're going to talk about the rational zero theorem. We're going to be able to use this to figure out any rational roots of a polynomial. So we're going to be given some function with whatever highest power. As long as we have integer coefficients, this thing works. And it says every rational zero of a polynomial with integer coefficients can be found by dividing the factors of p by the factors of q. The factors of the constant term divided by the factors of the leading term. Because we have positive times positive or positive times negative or any combination thereof, you're going to get lots of plus or minus sorts of answers. It also says recall all imaginary roots come in pairs. Okay, if you are given a conjugate, or if you are given an imaginary number, a complex number, you can use that to find the other one to then get to hopefully rational things at the end of that. Okay, so it's kind of a longer step process, but it's going to be relatively straightforward once you get into it. It's just going to feel like you're doing a bunch of meaningless work in the meantime. So for 41, we are given this piece right here. F of x is 1x cubed minus 4x squared minus 11x plus 30. I basically don't care about the 4x squared or the 11x right now. Okay, I want to find my rational zeros, my possible rational zeros. So this is a nice one because my coefficient of a, my leading coefficient, is 1, but the process is the same regardless. You're going to take plus or minus each factor of 30 divided by each factor of 1. Since 1 is just 1, we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Where these all come from, you can think of them as all over 1. All of those numbers that I wrote in black are going to be factors of 30, and then the ones on the bottom are all factors of 1. If I had a 2x cubed, I would have all of these that we just listed, and we'd have another row of all of those black numbers on top over 2. Where that kind of helps out in some regards, and it's kind of annoying in some regards, is you can simplify fractions. So if I had a plus or minus 2 over 2, that simplifies down to 1. I already have plus or minus 1 as a possible zero. Now, what this tells me is there's 1, 2, 3, 4, 5, 6, 7, 8 different things I could try in my synthetic division. I could just start guessing and hope for the best to find out one that's a remainder of 0. Or I can be a little bit more strategic about it if I'm allowed to use my calculator. If I'm not allowed to use my calculator, you just got to pick one and go for it. If you are allowed to use your calculator, what you're going to want to do is go to your y equals, and you're going to put this function, so x, if it'll let me write, here we go. It'll let me hit buttons I don't want to press. X to the third over minus 4x squared minus 11x plus 30. Notice that I had to hit an arrow key to get out of the exponent after the x cubed, but that's my function that I have. If I hit graph, I'm going to have this piece right here. So I'm looking, can't really point too efficiently. I'm looking at where it crosses the x-axis. So there's 3 spots. It looks like approximately x equals negative 3, at approximately x equals 2, and approximately x equals 5. Okay? So I had x equals negative 3, positive 2, and positive 5 as possible guesses. I'm going to pick one of those. It does not matter which one, and I'm going to use my synthetic division. I'm going to use positive 2. Okay? Nothing really special for why I picked positive 2. I just think multiplying by positive 2s is pretty easy. So this would be a 30 over here using our synthetic division, and we took the coefficients of each term. Remember, if you are missing a degree, put in a 0 for that coefficient. Bring this down. 2 times 1 is 2. Negative 4 plus 2, negative 2. 2 times negative 2 is negative 4. Gives me a negative 15. 2 times negative 15 is negative 30, which adds up to 0, which means that x minus 2 was a factor. So f of x can be written as x minus 2 times the stuff that's left. There's my remainder, constant, linear, quadratic term, x squared minus 2x minus 15. I can go further. If I can factor this, I'm going to. Depending on what you're given, you might be able to factor it just how it looks, which in this case, I can factor it to an x minus 5 times an x plus 3. Noticing that that gives me those other two things that we could have possibly done. If you aren't able to factor that trinomial because you don't see it or you're left with an a value that's goofy or whatever, you can start this exact same process over again from the beginning with just that remaining polynomial and keep trying. So now I've got 3 factors. Wonderful. Set each factor equal to 0. Oops, I'm getting ahead of myself on that one. X minus 5 equals 0, or x plus 3 equals 0, and solve each of them. These are all one-step equations, so x equals 2, x equals 5, or x equals negative 3, which is exactly what we had guessed based off of the calculator. Now, I'm letting you use the calculator on at least these homework questions, so you can just not have to guess 15 different times. Because if I had just started guessing and I had guessed x is 1, it would have given me a number other than 0 right here, and I would have had to try another possible rational 0. That gets kind of annoying. So I'm letting you use the graph just to identify where 1 might be. They're not all going to be nice. This one worked out very, very nicely. But you still need to show me your synthetic division and then your factoring and solving. Okay? Have a great day, everybody.